Hello, how do we solve this exponential equation? Without further delay, let us begin. 5 to the power of x plus 5 to the power of 2x plus 5 to the power of 3x is equal to 155. This means that 5 to the power of x plus this guy could be written as 5 to the power of x times 2 plus this also could be written as 5 to the power of x times 3 equal to, we can rewrite 155 as 5 plus 25 plus 125. Let's continue. 5 to the power of x plus 5 to the power of x times 2 plus 5 to the power of x times 3 equal to 5 plus 25 could be written as 5 square plus 125 could be written as 5 to the power of 3. Let's proceed further. Now, let's suppose 5 to the power of x is equal to m. Anywhere we see 5 to the power of x, we replace it with what? M. So we have m plus m square plus m cube equal to 5 plus 5 square plus 5 cube. Let's rearrange this equation now. So we have m, moving 5 to the left side, we have minus 5 plus m square. Moving 5 square to the left side, that will be minus 5 square plus m cube. Moving 5 to the power of 3 to the left side, we have minus 5 cube equal to 0. Let's continue. You will observe that we can put these guys in brackets. So that will be m minus 5 in brackets plus m square minus 5 square in brackets plus m cube minus 5 cube in brackets equal to 0. Let's proceed further. At this stage, let's recall some identity. The first one is a square minus b square is equal to a minus b times a plus b. The second identity is a cube minus b cube is equal to a minus b times a square plus ab plus b square. Take note of these two properties. Very important. From this line now, we have m minus 5 plus, applying this first identity to this guy, we're gonna have m minus 5 times m plus 5 plus, applying this second identity to this guy, we simply have m minus 5 times m square plus 5m plus 5 square. Everything equal to 0. You will notice that something is very common in this line. M minus 5 is common. M minus 5 is common. We can pull it out. So that will be m minus 5 into 1 plus m plus 5 plus this m square plus 5m plus, what is 5 square? 5 times 5, 25. Everything equal to 0. Let's proceed further. M minus 5. Now let's change this square bracket to round bracket into 1 plus, dropping this bracket, m plus 5 plus, dropping this bracket to m square plus 5m plus 25 equal to 0. Let's continue. M minus 5 times m square, m plus 5m, that is 6m, 1 plus 5 plus 25, that is 31, equal to 0. Let's continue. This implies that m minus 5 is equal to 0, or m square plus 6m plus 31 is equal to 0. From this line, m is equals to 5. Since we already know that 5 to the power of x is equals to m, let me show you where we got this from. It's from this assumption. Let's continue. This means that 5 to the power of x is equal to, what is m? M is 5. So we have 5. 5 to the power of x is equal to 5 could be written as 5 to the power of 1. Since the base is the same, we can claim that the power must be equal. X is equals to 1. Let's call this x1. This is the first solution. X1 equals to 1. Now, back to this quadratic equation. Let's solve it here by completing the square method. So the first thing we have to do is to transfer this constant to the right hand side. So we have m square plus 6m equal to minus 31. The second step is that we're going to add half of the coefficient of m and at the same time square it to both sides. The coefficient of m here is 6. Half of it will be divided by 2, all squared. So add 6 over 2 all square to both sides. So that will be m square plus 6m plus 6 over 2 all squared equal to minus 31 plus 6 over 2 all squared. I can combine this left hand side. So that will be m plus 6 over 2 all squared equal to minus 31 plus 6 over 2 all squared. That is, if you carefully expand this left hand side, you're going to have this back. Let's continue. M plus 6 divided by 2, that is 3, all squared, equal to minus 31 plus 6 divided by 2, that is 3, all squared. M plus 3 all squared equal to minus 31 plus 3 squared, that is simply 9. M plus 3 all squared equal to minus 31 plus 9, that is negative 22. If we take square root of both sides, we simply have m plus 3 equal to plus or minus square root of minus 22. M plus 3 equal to plus or minus square root of minus 22 could be written as square root of minus 1 times square root of 22. M plus 3 equal to plus or minus. Don't forget, square root of minus 1 from the complex number is I times square root of 22. This means that m is equal to minus 3 plus or minus I times square root of 22. Since we already know that 5 to the power of x is equal to m, this means that 5 to the power of x is equals to, what is m? This is m now, minus 3 plus or minus I times square root of 22. Let us take natural log of both sides. So that will be log 5 to the power of x equal to log of minus 3 plus or minus I times square root of 22. This left hand side could be written as x times log 5 equal to log of minus 3, this is 3, plus or minus I times square root of 22. Now, divide both sides by log 5. Doing that, we simply have x equal to the right hand side log of minus 3 plus or minus I times square root of 22 divided by log 5. Let's continue. At this stage, let's record this beautiful property. It says whenever we have log a over log b, this equal to log a base b. Take note of this. From this line now, we have x equal to, applying this identity to this quotient, we simply have log of minus 3 plus or minus I times square root of 22 base 5. From this answer, it is obvious x is equal to, considering the positive sign, we have log of minus 3 plus I times square root of 22 base 5. Let's call it x2, second solution. And also x equal to, considering the negative sign, we have log minus 3 minus I times square root of 22 base 5. Let's call this s3. Therefore, all the solutions that we have for these exponential equations are, the first one is x1 equal to 1, x2 equal to this guy, log of minus 3 plus I times square root of 22 base 5, and the third solution s3 equal to log of minus 3 minus I times square root of 22 base 5. You will observe that we have three distinct solutions for this equation. That's it. Thanks for watching.